Okay, let's take a look at this problem here. So this problem asks us to find uh, the parallel equivalent impedance, ZP. And it defines ZP for us right here as that little junction of 3. Okay. I will say in advance this problem is a little tricky, so just stick with me here. All right. They only give a few values. They give us a voltage value V right there, and then they give us this I current right there. Let's see what that does for us, though. And everything that's given is in a complex form already. So let's see what we can do. I'm going to call this this bunch here. Let's call that Z1. Okay. So that Z1 is going to be a parallel value. So Z1 will be equal to ZP. 1. That's fine. Okay. What that'll be is the combination of ZR3, Z of L. Okay, I'm just going to add those together. All right. But notice we don't know either of those values. So that's kind of puzzling for us, because how do we solve for it then? Stick with me here. Since we know this voltage here, we know it's also that voltage there across the capacitor. So we can find the current running through this capacitor. So let's do that. So I of C is going to equal V divided by negative J3, which is, you can say, here, let's say it like this, ZC. So voltage, so it was 75 and angle 15 degrees voltage. ZC is negative J3, which is the same thing as saying 75 angle 15, 3 at angle negative 90. So we divide these out. 75 divided by 3 gives us 25. 15 minus negative 90, that'll give us 105. Okay, amps for I of C. All right. So now that we have I of C, let's assume that we combine the ZP down. Okay, I'm going to redraw it for us over here. ZP, ZC, V, R1, R2, and this capacitor here, which I'm just going to put C. Okay, so now I know that this current coming in through here, I'll call that I. Then I know I of C going through the capacitor. So I'll call this current, I'll call it like I1. Okay. So I1 is going to equal I minus IC. Because at that node right there, it's I coming in, I1 going out, IC going out. Okay, so just a node. KCL law. Okay. So if we do that, we can write I in the right 4.5 at angle 36 minus 25 at angle 105. And if we break these down into component form, using the Im cosine theta plus Im sine theta j, using that, we'll get 3.64 plus j 2.65, and we'll subtract negative 6.47 plus j 24.15. Okay, now we'll just combine like terms, and combining like terms yields us 10.11 minus j 21.5, which when we break down to the phasor form is 23.76 and angle negative 64.81 amps. And this is I1. Okay. So now that we know I1, we can find Z parallel by saying voltage divided by I1 is equal to Z parallel, because this is still the voltage across. So now we can just go in here and drop the 75 angle 15. I1 we said was 23.76 at an angle 64.81. Okay, so that'll be 75 over 23.76. 15 minus, should be a negative right there, and you can't really see that, negative, minus negative 64.81, and Z parallel will be equal to 3 points. I'm sorry, this is Z parallel 1, by the way. This is just that first combination. So Z parallel 1, 3.16 at an angle of 79.81 degrees. Okay. Which is about, when we break it down to the rectangular form, is 0.56 plus J 3.11. Okay. So then now what we need to do is combine it one more time. So by doing that, Z parallel, this is the true Z parallel, will be Z of C ZP1 over Z of C plus ZP1. Okay. And doing that, ZC we said was 3 at angle negative 90. Z parallel 1 we said was 3.16 at angle of 79.81. ZC we said was negative J3 plus 0.56 plus J3.11. All right. And we can go and combine these down, multiply these out. We'll multiply, we'll add make it 9.48. Then we'll do negative 10.2 degrees. So then combining these down, we'll get 0.56 plus 0.11 J. And write it out here, 9.48, an angle negative 10.2 degrees. And then whenever we break this down into phasor, 0.57 at angle 10.92 degrees. So finally, we will get 9.48 over 0.57 negative 10.2 minus 10.92, which will give us a 16.63 at an angle of negative 21.12, which whenever we 16.63 cosine of negative 21 which will give us 15.51, and then when we cosine the sine, which give us negative 5.99 J. And please let that be right. And we're pretty darn close. So there we are. All right. Well, thank you, and I will see you in the next video.